Picture this. It's late at night, and the sky above you is a deep, endless black, dotted with countless twinkling stars. The world feels calm and still, as if the universe is holding its breath. Suddenly, out of nowhere, a brilliant streak of light blazes across the horizon. It's so quick you might almost miss it if you blink. That flash is a meteor, a chunk of rock or metal from space, hurtling toward Earth at mind-boggling speeds, lighting up as it tears through the sky. Some meteors travel at over 100,000 miles per hour. That's faster than anything we have on Earth, and it's hard to even imagine just how fast that really is. To put it in perspective, that's like flying from New York to Los Angeles in just a few minutes, faster than any jet, faster than the speed of sound. As the meteor plunges into Earth's atmosphere, it suddenly encounters something it never faced in the emptiness of space: air. The atmosphere acts like a giant invisible wall. The air in front of the meteor gets squeezed and compressed, almost like squeezing a balloon really tight. This creates an incredible amount of friction and pressure, heating the meteor's surface to thousands of degrees. Have you ever rubbed your hands together really fast on a cold day? They get warm, right? That's friction in action. Now imagine that effect multiplied millions of times. The meteor glows white-hot, its surface burning and melting as it races through the sky. This is the fiery spectacle we see from the ground, a shooting star. And this is where our cosmic journey gets truly fascinating, as we witness the incredible power and beauty of meteors plunging into Earth's atmosphere. As the meteor speeds through the atmosphere, it's traveling at tens of thousands of kilometers per hour, much faster than a jet plane or even a speeding bullet. This incredible velocity means the meteor slams into the air with tremendous force, and the friction it encounters generates an astonishing amount of heat, far beyond what we experience in our daily lives. Imagine the sensation of thousands or even millions of matches striking all at once, but on a much grander scale. The heat produced is so intense that it doesn't just warm things up, it causes the air around the meteor, and the meteor itself, to reach temperatures of several thousand degrees Celsius, hot enough to melt rock and metal in seconds. Remember those tiny air molecules we talked about? When they're hit with this much energy, they get so excited that they start to emit light, glowing brilliantly in the process. This glowing air forms the bright, fiery tail that streaks across the sky, a phenomenon we know as a shooting star. It's not the meteor itself that glows, but the superheated air and particles around it. But the story doesn't end there. The meteor's surface gets so hot that it begins to melt and vaporize, much like ice cream instantly melting on a scorching summer sidewalk, only much faster and at much higher temperatures. As the meteor continues its fiery descent, the extreme heat strips electrons from atoms, creating a superheated, electrically charged gas called plasma. This plasma glows intensely, adding to the meteor's spectacular display. The result? A dazzling, unforgettable light show in the night sky, a perfect example of physics and chemistry working together to create one of nature's most breathtaking sights. Sometimes the pressure from the air becomes too much for the meteor to handle. The intense heat, combined with the pressure difference between the meteor's interior and the surrounding atmosphere, can cause the meteor to explode. This explosion, called an airburst, can release as much energy as a nuclear bomb. Remember those glowing air molecules? When the meteor explodes, they release a shockwave that can shatter windows and even knock down trees. One famous example is the Chelyabinsk meteor, which exploded over Russia in 2013. The explosion was so powerful that it injured over 1,000 people and damaged buildings miles away. So how do we learn about these incredible events that happen far above our heads? Meteors and asteroids may seem distant, but understanding them is crucial for our safety and for unlocking the secrets of our solar system. Scientists use cutting-edge technology and innovative methods to study meteors, track their paths, and keep us safe from potential threats. Their work is a blend of curiosity and responsibility as they monitor the skies day and night. Special high-speed cameras capture meteors as they streak through the night sky, recording their speed, brightness, and trajectory in incredible detail. Telescopes, both on the ground and in space, help us analyze the composition of these cosmic visitors, revealing clues about their origins and what they're made of. By studying the light that meteors emit as they burn up in our atmosphere, scientists can determine their chemical makeup, unlocking information about the building blocks of our solar system. They often find elements like iron and nickel, and sometimes even traces of water, evidence that these space rocks may have played a role in bringing water to Earth long ago. But our efforts to understand and protect ourselves from meteors and asteroids don't stop with research alone. NASA and other space agencies around the world are developing advanced technology and global monitoring systems to defend our planet from dangerous asteroids that could pose a threat. One groundbreaking example is the DART mission, which stands for Double Asteroid Redirection Test. This spacecraft was designed to intentionally crash into an asteroid, testing whether we can nudge a dangerous space rock off course before it ever reaches Earth. It's kind of like playing a high-stakes game of cosmic billiards, using science and engineering to protect our planet. With the fate of Earth at stake, these efforts show just how far humanity will go to safeguard our world from the dangers of space. Meteors might seem dangerous, and well, they can be. But they're also fascinating pieces of our solar system's history. They provide clues about the early solar system and maybe even the origins of life itself. Some scientists believe that meteors brought water and other essential ingredients for life to Earth billions of years ago. Could these cosmic wanderers be responsible for the incredible diversity of life we see today? So the next time you see a shooting star, remember that it's not just a beautiful sight. It's a reminder of the incredible forces at work in our universe, and the mysteries that scientists are working tirelessly to unravel.